Are you really struggling to find the information buried deep inside your unstructured documents? It is time to unleash the full potential and power of Azure OpenAI and Service Embedding. In this video, I am going to demonstrate how to harness the advanced AI capabilities with cloud services and transform your document search and take it to the next level. With Azure OpenAI's advanced natural language processing and service embedding's powerful integration capabilities, you will be able to extract the meaningful information from your unstructured documents with ease and make an informed set of decisions. Whether you are a legal or healthcare professional or any industry where you are supposed to do the document analysis, then this session is specially for you. Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment. Unleashing the power of Azure OpenAI and service embedding for unstructured document search. So let's get started. Here is the agenda. First, we are going to understand what is LLM, large language model, what is a prompt and composition of a prompt, different prompt types, what is a chain of thoughts, standard prompting versus COT prompting, chain of thought prompting, React framework, then text splitting, how text splitting works in your LLM, what is the embedding, vector databases and Pinecone vector databases, and then Langchain Framework, followed by a quick demo to showcase this capability. Okay, so let's first understand what is language modeling, and I will explain it with the help of an example. Suppose you are given a sequence of word x1, x2, x3 till xn, and if I ask you what will be the next sequence of word, and which is nothing but we are going to find out the probability of the next word with the help of a probability distribution. So this is nothing but like if suppose there is a probability distribution function and where I input the value x1, x2, x3, and then based on that probability distribution I want to find out what is the next value. So exactly this is what we do in the language modeling, and let's understand it with the help of an example. So this example I have given you a sentence, the bird flaps its, and in the fill in the blanks I have given you these choices: tail, storage, wings, beak or GPS. Which one do you select? Obviously you are going to select wings because bird flaps its wings, right? It's not going to be tail or right, and the probability of flapping beak will be impossible, right? Because beak cannot be flapped. So wings is the only thing which can be flapped. So this is how the probability of the next word is calculated, and based on that the answer is provided. So now let's understand what is prompt. Prompt is, in the prompt engineering, prompt is that where you are giving a specific input or a task to a language model, and then language model generate a desired output or a desired outcome. Like in this example, you are asking about the George Washington and it is giving you the answer of the George Washington. So this is called a prompt, and the concept is composition of a prompt. Prompt consists of 4 different parts: instructions, context, input data and output indicator. So let's understand each of these. So whenever a prompt is created, these 4 elements have to be there. Without that you cannot complete the prompt. Now let's understand what is instructions. Instructions are the tasks which need to be performed by the language model. Context. Context is a additional information given for the prompt so that it can be fine-tuned. Input data. Input data is a data which will be used in the model to process the information. And then output indicator is how the output should be generated, in which format the output will be generated. So let's understand it with the examples. So this example, suppose you provide a prompt like summarize the following text into 3 sentences or less. So summarization is an instruction. Context is a, in this example, the length is a context because you want to summarize it into 3 sentences, right? And then input data is text because you are going to provide input data for this, and then it will process that. And then output indicator is actually you are providing a summary instead of detailed output. So this is a output indicator. So this is how the whole prompt works. Like let's take another example where, like this example, translate the following text from English to French. Obviously text in English is your input, and text in the French is your output indicator, and the language is your context. In which context you want to translate, you translate against the English context, right? And then the instruction is translate. So this is how your composition of prompt works. Prompt types. So there are 3 prompt types: zero shot, one shot, and few shot. So why zero shot is used? Let's understand it. Whenever you want a model to guess the best effort without having any example, then you use zero shot prompting. In this prompt, there is no example given to a prompt, no input data is given to a prompt, and the model actually relies on its own knowledge, and it does not require any example. Because it's not that you don't want to give the example, it is that you don't even have an example. So that's why you are not giving an example. One shot prompting, in this case, you only provide one example and then tell the prompt to figure it out, the result outcome. And then few shot prompting, where you provide few examples, and then this helps you to train these examples are training the model and then providing you the output. Then now after you give these examples, you are asking a question. So based on that training which it received from the examples, it is going to give you the outcome. So this is one example of prompting. So in the zero shot prompting, if I ask how the dog looks like in a certain environment, like in a snow, and this gives me this particular answer because it knows how to create a dog and how to create that environment. So it's giving me this answer. If suppose I say one shot prompting, in one shot prompting I provide the whole detail, one example of a dog which is given, in that it is, the color of the dog, the breed of the dog, the nearby mountain. So that one example I'm giving, and based on that one example, it is creating that whole, output, like these dogs. And then few short prompt is that I'm giving multiple examples, and based on those multiple examples, I am now asking a question, and that question is answered based on the training it received from multiple examples I have provided. Chain of thoughts. Let's understand this wonderful concept. The chain of thought is a reasoning technique. And what do we do? If suppose I ask you a question and I tell you that you provide the answer in a step by step, step 1, 2, 3, 4, 5. And in that case, if I ask a question and I don't provide any example, then it becomes a zero shot prompting, right? And in that zero shot prompting, if I tell you to provide the answer step by step, so what you will do, you will put your reasons and you will say that, okay, this is a first step. Then the second reasoning is that this is a second step, this is a third step. Like that, you are going to provide the chain of thoughts. And this is called the chain of thought prompting. So what is the difference between chain of thought prompting and standard prompting? Standard prompting is one example given here. And suppose I ask you a question that this is my question. Sean has a 5 toys for Christmas. He got 2 toys each from his mom and dad. And how many toys does he have now? So my answer is 9, right? Now again another example. John takes care of 10 dogs. Each dog takes 5 hours a day to walk and take care of their business. How many hours a week does he spend taking care of dogs? So the answer is 50, which is wrong. Why this answer is wrong? Because there is no step-by-step reasoning done in this, and the answer is given without the step-by-step reasoning. But if you have the chain of thought prompting and you ask the same question, it will give a reasoning of this, and that reasoning will be hold true. Like in this example, if you ask the same question with the chain of thought prompting, and it will give you the intermediate result that he got 2 toys, he already have 5, and then he added 4 more toys, right? And then 5 plus 4 equal to 9. So that is how the whole answer is coming as 9. Similarly, for this John's example, this is a step by step. And if you think about how the human works, human also works exactly the same way. They actually think one step at a time and then go with the step 1, 2, 3, 4, 5 and then give the result. So the same concept is being used here. The chain of thought prompting is nothing but a step by step chain of thoughts which is linked together to provide you the answer. Okay, so now let's understand what is a React framework. So React framework is nothing but a reasoning and action. So first, whenever you think about anything, right, what you do, you actually have a reasoning, and based on that reasoning, you follow a certain step. So like this example, the LLM model also does the same thing. LLM model actually do the reasoning, and based on that reasoning, it performs some action. And that action is performed, then again there is a next set of reasoning, and then the action is performed. If you think about a student doing his homework, what does he do? He read a question, he understand what this question says, he write first step, that is a action, then he go to the next step and he reasoning for the next step, and then he again provide an answer for that next step, then again he goes to the third step and then write an answer for that. So it is a reasoning and action. Action is writing. So this is exactly what humans do. That is what is called a React framework. Okay, what is text splitting and why we require text splitting capabilities? So let's understand it with an example. Suppose I ask a question and I created a prompt, and the prompt is that what was the role of Harry in this book? Suppose this is my question and I'm creating a prompt. Now large language model need to go through this process. First it will do what it will do. It will create a chunk from this big document, right, where I want to ask a question, and that chunk will be created. So there will be a different set of chunk A, B, C, D, E, F, and suppose this answer is given in the chunk A, B and C. So what it will do, it will go to the chunk A, B, C, and then based on that chunk A, B, C, it will put a API call to extract that data, and based on that small data set, which is chunk A, B, C, instead of chunk thousands of chunk, it will give you the result, because it don't have to search so much detail from a large data set. It will only go through the small data set and find the details. So this is why the text splitting is very, very important. Okay, so now let's understand what is embedding. So let's again understand it with the help of an example. Suppose I created 3 sentences, and these are my sentences, and think it as if it is a prompt. So first is I want to order a large size pizza. Second is I have a huge size pizza, and then third sentence is in a different language, Spanish. And then I want to find out what is the answer from this. So if you see, these are the chunks, right? And how do I place this data which is coming from these 3 sentences in a particular area in your vector space? So this is your vector space. In that vector space, I want to put this sentences in a certain space. So suppose pizza comes here, pizza things are here, and then the different thing more than pizza will be kept somewhere else. So that whenever somebody asks a question regarding pizza, I know that these are the area for pizza and I can find it out. But you might be thinking, how does it know that this area belongs to pizza? So what we do, because the natural language is not understood by computers directly. So what they do, for every object they created a embedding number in a numerical form, right? So that numerical form is kept, and that numerical form helps to you find it out whether the subject, if the subject is related to pizza, and then these are the numbers given as a vector, and that number belongs to the pizza or pizza related items. So then it will find out the chunk for that particular item which you are looking for. So the process of converting this object in the vector space with the numerical identification is called the embedding process. So how the embedding works in the vector databases. So let's take an example. Suppose this is your context, okay, and in this context there is a query that tell me something about the Empire State Building, and the context is that I am providing the whole story about Empire State Building, that this building is how many stories, it was built in this time, and what is the length, and all that details. And then you send it to the encoder in an embedding model. So what does it do? It has a query and it has a context, and based on that context and query it find out what are the element in the vector space which it need to give a result, and based on these two it will provide you the answer. So this is an example. Suppose this is a vector space, this is a query, and this is a context, and based on that query and context it will give you the answer, and that answer will be your contextual answer, and that answer will be given here. So this is how the embedding works in the vector databases. Okay, so now let's understand a very critical and important part of this whole session called Langchain Framework. And Langchain Framework is used for developing the applications powered by the language models, and this is a wonderful framework. It has two principles, data aware and agentic. Data aware means that it can connect to a language model, okay, and these language models we can connect with some external data sources. So that means it is connecting a language model to the external data sources. That is why it becomes very, very powerful, because at the end of the day, if your model cannot connect to the data sources externally, it is not going to unleash its power. Second thing is that it is a agentic, which means that it can enable a active interaction with for the decision making. That means you can create multiple agents, and those agents works for you based on the command you provide those agents, right? So this way your data aware thing helps you to create decisions based on the data sources, and agentic helps you to create a specific agent which does the job for you and based on the decisions you are making in the language model. So what is the advantage of this? It is a comprehensive and contextually rich responses you are getting because you are connecting to the data sources, and it is very powerful and creates a very differentiated application which really does wonders. So this way Langchain, because it's a framework, it provides all the nitty-gritty and required things for a developer to create this kind of data aware application with a agentic language model applications. So let's understand what are we going to discuss in this demo scenario. In this demo scenario, we will create a Langchain project in the Python. We will scrap a help file from the internet and save it in the local. We will deploy the Pinecone Vector DB database and create an index into it. We will split the text from the help document. We will write a Langchain embedding code to save the text and store it into the Vector DB. Then we'll create a Langchain code to query the Vector DB database. And finally, we'll create a Streamlit application to input the question in the UI and display the results. So let's get started. But the index is empty, and if you see, there is nothing in this index. So now what we are going to do, we are going to create, because this index is still initializing, let it complete. And here there are API keys, and if you come here, these are the API key and the environment information and API key. There is a value, you can find it out the value from here. So you have to store this value and then environment value, which will be used in your Python project. Okay, so first and foremost, I'm going to download all the help files of Langchain in this folder, doc for Langchain, and for that I'm going to use the wget command, and the wget command is here. So this wget command will actually get all the documents recursively. R flag is recursively the HTML files in this path from this particular URL. So this URL is actually the URL for the Langchain, and the moment I start doing it, it will download all the files, and if you see, it was empty. Now when I refresh it, lots of files are coming. So let this command execute fully, and once these commands are executed, you will see that there are lots of files which is captured in this directory. Now we have all the necessary help files in the HTML format already downloaded with the wget command. The next step is to do the ingestion of this file, and as I explained you in the session that we need to actually split this documentation. So for that we are going to use Langchain. In the Langchain, first of all, I am going to import these libraries, and second thing is that I'm going to use the vector DB database, and vector DB is the name of the vector DB is Pinecone DB. I'm initializing that vector Pinecone DB, and this method is a custom method which I have written. This method will make sure that the files are ingested from this particular path. So in my case, I have copied the docs in this particular path, and then I'm creating the loader. There is a special loader created by the Langchain called read the doc loader. This read the doc loader, actually what it does is it actually goes to the file path, when then encoding is UTF-8, and this loads it, and loader.load actually creates a raw document out of it, which is a single document, right? And that single document you are actually recursive character text splitter function you are using. This function actually does the recursive, it goes recursively, and then create a chunk of 1000 characters, and then whenever there is a new line, or these are the characters, so these are the separators. So whenever there is a separator like this, it actually split that and create a chunk of this 1000 per chunk 1000 size. And once the it calculates the find the length of the raw documents. So this is a raw document length, okay. And then what it does it now, because it is text splitter is already applied, now in the text splitter it splits the document, the raw documents, because this is just a configuration of the text splitter and this is the real work which it is doing. And then it is printing that splitted the number of documents, these many documents. And now what it does is it creates a for loop. In the for loop, it goes doc in the documents, which is this documents, and then it goes into the doc.metadata source, new URL, old path dot replace Langchain doc http doc.metadata.update source new URL, which means that it is actually updating the document, the metadata of the document. Okay, so this is very important because it is going through this doc, the document, and in that document it is getting the old URL, and then in that wherever the https colon is written, it is copying it as a Langchain doc, okay, replacing it, and then it is updating the metadata of the documentation. So it is doc.metadata.update source equal to new URL, which means that it is updating the source. Now it is going to insert this document to the Pinecone DB. So this is just a print statement, and this is a magic command. OpenAI embedding, OpenAPI key, the key is taken from the environment variable, and then pinecone.from document and embedding. Whenever you do embedding, these are the parameters. First of all, document you need to provide, embedding you need to provide, and if you remember embedding, we have already created an embedding, and this is the embedding here, and then the index name, and this is the index name which we created in the Pinecone DB. And now start ingesting it. So let's run this command, ingest command, and see what happens. So I am going to run this command ingest. So first of all, before we do anything else, what I need to do, pip in shell, which creates a shell environment which I have already created, but it is just invoking that shell environment. Then I am going to run this command python, and then here I am going to say ingest.py, and this is going to ingest all the documents which is kept in this particular location. and this particular document will go into the Pinecone DB. So what we will do now, we are going to wait for this command to run, and now this command is running, and this is just a warning, so don't worry about this warning. But actual command, when it runs, it will show you how many chunks are added, and if you go to the Pinecone DB, you will see that this chunk is not there, but after some time you will see the index size is increasing. So now you see that Langchain, the index which we have created, is ready. Initially it was initializing, and you see that there is nothing in this index, but after some time when we refresh it, you will see that lots of chunk of document is there. So now you see that it is going to load 1049 documents, splitting this chunk and going to insert this many chunk to Pinecone. So now if you come here, you can see that vectors are increasing as and when we are ingesting the data. You can see that vector is increasing 2944, and now you will see the 3040. So like this, it is going to increment the chunk of data. So finally you can see that there are total 7575 vectors already ingested, and the same is depicted here. There are total in the 7575 vectors are inserted into the Pinecone DB, and this is exactly what it shows. So now when we downloaded the Langchain documentation, this is how the metadata looks like. But I just want to show you something, that when we change the metadata, Langchain doc, how it looks like. This is how after changing the metadata it looks like. And you remember that we have done the metadata change here. If you come here, we have done the metadata change here. So instead of HTTPS, we are actually changed it to Langchain doc. Everywhere where it is HTTPS. If you come here and see, I have also added the same thing here. So everywhere it is going to be inside, it is going to be HTTP, but after making the changes, it is going to become like this. So this is a major difference when we do the metadata change. Okay, so now let's understand the main part of the application, which is actually calling the OpenAI and then finally searching the documents from Pinecone DB. So this is very self-explanatory, that I'm importing this Pinecone DB and then Langchain vector store, and then in that I'm importing the Pinecone. This is very important method conversational retrieval chain, which actually creates a chain for chatting with an index, which is a Pinecone index in our case. And this is a chat model, and here we are using OpenAI model, but you can use Azure OpenAI as well. And then here it is a OpenAI embedding, and obviously it's using the dictionary list and other basic items in Python. This part of the code actually initializes the Pinecone DB with the environment variable already stored here. And if you know that where the environment variables are getting stored here, I have actually stored it in the configuration file. For my example, I have stored in this configuration file all these variables. So all the variables are stored in the column, separated by the column, the value, and the separated by the column. Like in this example, environment index, key and everything. So then after that, what I am done, once the Pinecone is initialized, this is a main method which is getting called. This method, what does it do? It actually creates a run LLM method. This run LLM method will be called whenever you try to run the LLM and find the document from the Pinecone DB and get the result. So this is very simple. First you are going to create a embedding, OpenAI embedding, and this is OpenAI embedding object which is getting initialized. This is a doc search. In the doc search, we are actually searching from the existing index. Okay, so from existing index, method does the same, and then it is you need to provide a embedding as well as the Langchain doc index name, because in our case we have kept the index name like this. Then we are creating a doc search. Now this is a main object. So what does it do? It actually, if you click this, it will tell you that what does this method do for you, right? So in this case, what we are going to do, we are going to, from the existing index, okay, we are going to use the embedding, okay, and that in the embedding, this is what exactly we are doing. We are actually getting the Pinecone DB, we are creating an index and embedding, and that embedding we are creating a doc search object, and then we are creating an instance of the chat object. And obviously when you create a chat object, you need to put a temperature parameter so that you can tune this. And then this is a very important method where it actually creates a conversational retrieval chain for index. So what does it do? It creates a chain for chatting with an index, right? And then here if you come and if you see this particular method creates a doc search, and then this particular method, I think this is copied 2 times, so let me delete it, or I would say that comment it. And then here this method, conversational retrieval chain method from LLM, it actually uses this doc search as a retriever and then return the document, and it actually initialize it with the stuff. Initial chain type is stuff. There are multiple chain types. You can go through the documentation of the Langchain. There are multiple chain types in this method. And then this is a most important part. So it returns a QA object, which is nothing but a conversational retrieval chain, and it also returns the question along with the query. Chat history. In that chat history, it creates a chat history. Whatever was posted in the chat, it is copying that information here. So let's run this command and see what happens. See this, when we ran this command and we ask the question, what are the Langchain use cases? So it gave me the answer. This is a retrieval chain question, and then chat history is the answer. Now the chat history was initially 0, but now it is initialized with this answer. So with this we could create a method with couple of line of code which actually goes through the Pinecone DB index, and then with that index try to find out the documentation based on our query string, which is very important part of our demo. Okay, so now with this all, what we have done is we have ingested the data, we have created a core functionality of our application. In that we have created a run LLM function which actually creates an embedding and get the data from the Pinecone DB. After the search is done, it is creating a conversational retrieval chain object, and it is retrieving the value. So that means it is actually giving you this outcome in nutshell, which means that query and then chat history along with this. So now let's do this. Let's convert this whole application into the chatting application, and the best option to do that is we are going to use Streamlit. So for Streamlit, this is a code I have kept, and first is that we are going to import the set and typing. Then we are using the backend.core, which is here, and then run LLM function we are going to import, which we just described here. Then we are going to create a create source string function. So this function, what it will do, if you insert some URL, and then it is going to return the strings, so which means that it is going to get the source URLs from the document. If there is a source URL, it is going to extract that source URL from it. It is using the set here, and what it is doing is it is actually trying to enumerate from the list, and all the source list it is getting, and then returning that as a single string. So now after that we are going to use the Streamlit, and in the Streamlit we are creating a header with this name helper bot, and then this line, first we are going to check if Streamlit has a session state, okay, and then we are going to copy this session state here. Okay, so if you see, this function takes a set of strings, source URLs as an input, and return a string. It creates a formatted string containing the source URL from the set. That means it is going to create a formatted string from the source URL which is getting here. So then we are actually creating a header with this name Langchain helper bot, and this particular line, it actually there is a if statement, and this checks if there is a key exists in the session state. If that means that the session state is going to be empty initially, so if this is not empty, then it's going to work a different way, but initially it is going to be empty. So it is going to initialize empty list if there is nothing exist, and if there is something already there, then it is going to initialize this with the chat history. So chat history, when you type first sentence, the chat history will be added there. Second sentence, so it will add the first and second both as a chat history, right? So like that it keep on adding the chat history. So these are the session variables. Now if you see this particular thing, it is actually created a button called submit, and when you submit this button, it is going to create it is going to populate this prompt variable, and this prompt variable will be, and this is going to create a placeholder, enter your message here, and this is a input is a prompt. So now we will see it happening. So even if you don't understand it fully, but when you see it happening, you will be able to visualize it. Then after that it checks the prompt. If prompt has non-empty value, which means that there is some value in the prompt field which is here, that means you have entered some value, then this code will be running. So this code will be running, there will be a spinner, that means there is some spinning thing coming, which will be saying that it is generating a response, so that user can get a information that something is going on, processing is going on. And then it is going to call our old friend generating the response to the run LLM method. The run LLM method which we have used here, the same run LLM method will be called, and this time the run LLM method will be called with the help of prompt, because this is a prompt you are entering here. So the same prompt will be entered here, and then it is going to get the history, chat history from the whatever the history was there initially, it is going to get that history from here. So that means this will include the chat history, right, from the earlier history, and then you will add the prompt. So that means you are training the model with the chat history plus your new question. And then after that, this code extracts the source URL from the generated response. This is the same function which I just shown you, and it is giving a formatted response, so that you can format that response, okay, using the create source string function which is here, okay, create source string function. So then once that is done, then what you will do, this message is a message which is getting called in a loop to display each user query and its corresponding generated response. That means this message will be getting this. So message function, what does it do? Message function, the user query which you are generating along with its response, okay? So that is what it does. So, and then you are returning the message generated response. So let's run this command and see what happens. For this I am going to go to the terminal, and I am going to say Streamlit run, and then main.py, and immediately it will run the Streamlit, and it will show you that where the Streamlit is running. So it is running here. So let me show you how it works. You can see that this Streamlit is here and it is prompt. So now you understand what when I say prompt means what. Prompt is a variable, and this is enter your message here, the same method I just explained you. Prompt, and enter your message here, and the button name is submit. Now I am going to say that who invented Langchain, and it is generating the response, and these are the source strings, and this is the answer. Now let me ask another question. Where does he live? So again, if he knows the answer, it will provide you. If he does not know, so he does not know. So you don't have that information. That is okay. Now let's ask, what is this conversational method which we were talking about. So let's understand what is conversational retriever chain. So here what I'm going to say, what is conversational retriever chain method, and let's see what does it do. So conversational retriever chain is that it is a retrieval focused system that interacts with data stored in a vector store. It utilizes advanced techniques like context-aware filtering and ranking. It retrieves the most relevant code snippet and information for a given user query. Retrieval chain is designed to deliver high quality, pertinent result while considering conversational history and context. Along with that, it also gives you source. So with this, you saw that how beautifully Langchain, with a couple of line of code, it's not even 100 line of code, it is like very small code snippet. First code snippet does this backend work, which is nothing but a run LLM, run LLM file per function. Second code is ingestion code, where it ingests the document, and this ingestion code is also simple, right? It splits the document and it is, inserting the document into the Pinecone DB. And then the third code is the main.py, where it is actually doing the chatbot work for you. Thanks for watching, and do not forget to subscribe and hit the bell icon so you don't